video. When I think of squiggles, I think of this. This was a infomercial. It was over an hour and a half long, like super late at night, right? And this person put it on YouTube, cut it down, and clipped the best bits. Here we go.
I remember I've seen
Oh, hold on, my sound.
Video devoted to the rainbow sponge. The Army Arts and Crafts Department sent me to Korea. Now, not a sponge. This is so dense. 3 sizes because I can't stand just one size. Another thing is the hygiene of the sponge. I squeezed and squeezed and squeezed and squeezed. No cloud on this arm. Cleaning lab on this arm. Now, if you do get it on your hands, gloves are incredible. I have a pure love sponge that is absolutely pure. Oops, a virgin edge. Oh my gosh. I'm sorry. Oh, I want you to look at all of those wiggles. Oh my gosh, wiggles.
Oh, we should listen
Oh
to
my
Grace
gosh,
Salad now.
I love to
Yes.
wiggle the whole thing. There are many other surfaces that you can sponge on. I'm sure you would. Of course you can go straight. Oh my gosh. Are they incredible or what? And it's done. Yes.
This is my grandma.
Yeah. Is what?
I just want to be this happy.
Look at that.
God damn, Meg.
Why is she doing that?
She went to Korea.
Oh my gosh. Now, think, go this way, and now we think, oh my gosh, oh my gosh. Look at that.
I was always that excited.
I know, I just
This reminds me of my old art teacher from primary
It
school.
is so
Her name
hard to
was
stop.
Miss Green. She was the best. She looked
Would
like
you
that.
watch stamps?
Part 2, stamps.
Let's watch it. You guys know that like SpongeBob thing, or it's like on Italian. Every time he starts talking
I love
about
it.
math.
I just aspire to be that happy
What's that
someday.
called? The rainbow sponge?
Oh yeah, if you just type rainbow sponge or sponge squiggles, you'll find it. Pretty amazing. The original, again, is like an hour and a half long infomercial. We're just sitting there, just like showing off the rainbow sponge.
That's what she said.
I want to be that happy someday. All right. I have stuff for you, which I said I was going to pass out while I was going, and I totally did. All right. So here it is. We're starting on the last one. So number 6. Okay. Of course. Make sure you get your A game today. Rest in peace, Nelly. She's not here. My advice is if you get sick, is either like and subscribe, right, and do your best, or just literally drop out.
Wait, Mr.
So.
Mac, what are you Well, take one for the team. There has to be 4 other people going home. I will go home. I'll take one for the team. But who else is going to go home? Until they close school.
5 more people.
Until Valley too.
5 more people. Oh wow.
Okay, let's almost go home.
6.
Can we send you home too?
All right. Yes. Let's all go home. Go home. Go home. We are. Okay. I decided to add some easier ones. Oh, hold on. Where did I leave you the other day? When we had this. Did I leave you with number 3? Should we finish it?
You left us with I have to look.
I really love sister.
What?
I think it was that.
I can't hear you. Yes. I'll get those 2.
She has
We left with number 3. We didn't finish it.
We didn't finish 3. Okay, let's finish 3 first.
No.
We'll get into it. Anybody else need a triangle worksheet? The original, the OG?
Wait,
I gave you the extension
When?
just now.
She does.
This is the OG. Yeah, you were absent, right? There you go.
I have to keep
What?
track of her. 'Cause she won't
This guy from yesterday, yeah. Let's start on that one.
On Monday, we just went over the quizzes, right?
Right, and then Tuesday we did this.
Yeah.
All right, so we're not gonna do 4 yet. We're gonna finish up 3. So let's finish up 3,
It wasn't good.
and then we'll do 6, 5, and then a
2
little bit of
pieces,
4.
you feel
We're
like
lucky. All right, here we go. 3.
Cozy.
To catch you up, if you weren't here yesterday, or if you just need a recap because we stopped in the middle of it. Angle C and angle DEA are the same angle. They measure the same way, and they're 90, right? So that's just saying that DEA and angle C is 90. Yeah, there's a lot of information you can give me about this.
Crazy.
Do you guys remember we played that game the other day and I said, here's two triangles, tell me something about them that I don't want to hear but is true, right?
Yeah.
A lot of proofs, you can find a lot of true information, right? For instance, if that's 90, that's 90, right? But we need to think about, is that going to be helpful or not? Especially when we're first learning, because it's going to make our diagrams super crowded with information, right?
Wow.
And I would rather streamline it a bit. When you're doing it, don't be afraid and write down everything you see, right? But in general, we're going to streamline it today. So yeah, I know that's 90 as well, but I'm not going to write it because it's just going to make our diagram messy. Things are going to get a little crazy today, okay? So, here we go. We're going to prove that AD, this, times BC will give us the same number as AB times DE. Really what we mean is that we're going to show that those parts are proportional and we're going to move things around with algebra. So my job is going to prove that this triangle and this triangle are similar. Now remember what similar means. Congruent means everything's the same. Same angle, same sides, right? They all match up. They're the same. Similar means that their angles are all the same, but their sides are proportional. And remember, proportional means something like this. Where is it? Something like that. Okay? Where the sides are proportional. Okay? We're going to have a division statement of equality. So, here we go. Remember from yesterday that to prove similarity, that's what that squiggle means, right? We can use angle, angle squiggle, which is angle, angle similarity. We can use side, angle, side similarity. And we can use side, side, side similarity. Now, spoilers, do we know anything about the sides? No, we know nothing, right? So we're probably not going to use those two. Yes?
Can you explain the similarity thing really fast?
So, congruent triangles are literally the same. Similar triangles have all the same angles, right? But they're going to be proportional. So for instance, this triangle and this triangle could be similar if I write 3, 6, 4, 8, 5, and 10.
So it's like a ratio?
Yeah, there's a ratio, exactly, right? And the ratio can be expressed as division, right? 3 over 6 is the same as 4 over 8, is the same as 5 over 10. They're all a half, right?
Yeah.
Does that make sense? Yeah. Okay, good. Excellent job. All right, so we're going to prove that two angles are the same because we don't have any side information, right? Already we have one, right? If we can get another angle, we're good. A thing you need to be looking for constantly, right? You know how vertical angles always shows up, right? This is probably as common as that. Notice that the big triangle and the little triangle share angle A. They both use it. Does everybody see that? Yeah. How the big triangle has angle A as an angle and this has that. They perfectly overlap, right? So we're going to say angle A is congruent to angle A by shared angle. It's kind of like shared side, right? They literally share that angle. They overlap, right? This triangle takes that angle and so does this one. Is everybody cool with that? By shared angle is what that says, okay? Are we good with that? All right, then we can say by angle, angle similarity because we have two matching angles in this triangle, two matching angles in this triangle, right? The triangles are congruent. So by angle, angle similarity, triangle, let's do small triangle first, that's ADE. Again, I write alphabetical order when I can. And then the big triangle. Now let's match up stuff. So angle A is going to be the same for both triangles, right? A goes with A. Angle D is this angle on the small triangle. So it must go with angle B on the big triangle because it's the remaining angle, the last angle we don't know, right? And then E must go with C. Everybody cool with that? Now we've shown that they are similar. We know that their angles are the same and their sides are proportional. So while it would be true to say that angle D is the same angle as angle B, right? They match up, D and B, right? We're not going to write that because that's not very useful. We want to know about the sides, right? So I'm going to say by CSP. Remember CCP? CCP is corresponding congruent parts. If the triangles are congruent, then their parts are, right? Now we're going to use CSP. Corresponding similar parts, which means if the triangles are similar, then the sides are proportional and the angles are true, right? So by CSP, since the triangles are similar, which we just showed, right? The stuff that matches up is going to be proportional. So I'm going to write that AD, that's talking about the line segment here, okay? I'm not using a line on the top because I'm talking about how much it measures, okay? Divided by AB. You see how those go together? First and second, first and second? They're going to relate the same way that DE, second and third, relates to BC, second and third. The same way that AE, first and third, relates to AC, first and third. Okay? That's what it means to be proportional. So look back over here at these triangles. Notice that 3 over 6 relates the same way that 4 does to 8, right? And the same way that 5 does to 10. What do those all simplify to? A half. They all relate by a half. 3 is half of 6, 4 is half of 8, 5 is half of 10. Now, if you look at it the other way, you could say 6 is double of 3, 8 is double of 4, 10 is double of 5, right? So it depends on which way you look at it, right? Going from small to bigger, big to small. I started with small to big, right? So how do they all relate? We don't know, because we don't have any numbers, right? We don't know if it's like half, if that's like, you know, this side is like 5 times bigger than this side. I don't know, right? But I know however it relates, they all relate the same way. That's what similar triangles are about. So if this were 6 and that were 12, that would tell me they relate by double, right? So if I knew this was 4, I would know this was 8, right? Something like that. So that's what this means. AD relates to AB, the same way that DE relates to BC, the same way that AE relates to AC. Those are the sides that go together. Are they congruent? No, they're not, right? AD is not the same like this is, but they are similar. Does that make sense? That would be about 50 there. Okay. So, great. We have an equality here. We have an equal statement, an equation. We need an equation, right? That's good. But the problem is this is all division, that's multiplication. So let's look at what we need. AD and BC. Here's AD and BC. And we need AB and DE. So we don't really care about this guy, right? What we really want to focus on is this, okay? That has the stuff we're interested in. AD and BC, AB and DE. So here's what we're going to do. Before I get into that, I'm going to show you a little bit of algebra, okay? And you'll actually like this, I think. If I have x divided by 2 equals 5 ninths, how do I solve for x? What do I do to get x on its own? Fractions are just division, right? That's x divided by 2. How do I undo divides by 2? Okay. Yeah, I'm going to multiply both sides by 2, right? And when I do that, timesing by 2 and dividing by 2, that just undoes each other, right? That's 2 over 2. What's 2 over 2? 1. So I do 1 times x. You see how it basically just goes away? It becomes 1x. Over here, what that becomes is this. Most of you guys wouldn't show this work, but I'm going to do it. Multiplication happens in the top. Division happens in the bottom. That's what fractions are. This is 5 divided by 9, right? I've got division going on. I've got multiplication. You can do it in any order you want. I'm going to write it like this. 5 times 2 in the top and 9 in the bottom. Remember, multiplication in the top, division in the bottom, right? So multiplication goes in the top, division goes in the bottom. You don't need to put it over 1, but you can, right, and do that. That's fine. But really what it means is that, look, multiplication goes in the top. So what is x? X would be 10 over 9. Are we cool with that idea? Look back over here. Okay? I'm focusing just on that. That's all I need, right? I don't care about this guy. All right. So what I'm going to do is I want AD and BC to be on the same side and multiplying. AD and BC are currently separated. So I want to move BC over. Well, it's being divided, right? Divide by BC. How do I undo divide by BC? Well, the same way I undo divide by 2. Undo divide by 2 by timesing by 2. If I want to undo divide by BC, I'm going to multiply by what? What am I going to multiply? By BC. To both sides. When I do that, BC divided by BC is 1. 1 times D is just DE, right? That's why they go away. Cancel, right? BC divided by BC is what we're doing here. It goes away. BC times AD goes here. In the top, remember multiplication happens in the top, division happens in the bottom. I wish I had you guys for algebra. I feel like we make fractions way too complicated. It's really that simple. That's how that works. Now great, I've got BC and AD on the same side multiplied. They're in the wrong order, but that's okay, right? 3 times 2 is the same thing as 2 times 3. That's fine. But now I gotta get AB and DE together. So what am I gonna do? Yeah, multiply by AB to both sides, right? When I do that, this goes away because AB divided by AD is 1, right? And 1 times anything is itself. So I get BC times AD over here equals DE times AD. All right, well, I wanted BC and AD on the left. I've got that. And I wanted AB and DE on the right. That's good, but they're slightly out of order, right? Is it true to say that 2 times 3 is the same thing as 3 times 2? Then I should be able to just write this like AD times BC equals AB times DE. Right? That's all good, right? I can flip those. 2 times 3 is the same thing as 3 times 2. BC times AD is the same thing as AD times BC. Cool. And now I'm done. How do you feel about that? Yeah.
Like I get like the first part, like getting AA and like multiplying with BC and all like that stuff.
But you don't get this.
Yeah, I don't know how.
Got it. All right.
I don't know how you know that like AB is for AB. I just like this.
Thank you for being honest about that. I'm going to back up and go over it again. So I'm going to start from the beginning, but when we get there, Mark, I'll pay extra attention to that. All right, so check it out. Does everybody agree about the shared angle? Do you see it? Hey, I need you. I'll give you a break in a little bit. Does everybody see that this angle is shared by the small and the big triangle?
Yes.
Okay. Now I've got double angle for both triangles, so they're similar. Cool?
Yeah.
How did I match up their parts? Well, A goes with itself because it's made up of this angle right here, right? D goes with B because they're both the unknown angles. And E goes with C because they're both right. Okay? Remember CCP. If the triangles are congruent, then the parts are congruent. And when we check the letters to see what went with what, right? That was CCP. Same thing for similar triangles, but it's CSP, corresponding similar parts. Angle ADE and angle ABC are in the same order, so ADE and ABC would be congruent. So yeah, we could say this, right? That's true. Remember, similar triangles have congruent angles. That's fine. So it's pretty similar to CCP. However, for similar triangles, the sides aren't congruent, right? They're proportional. So when I write AD and AB, they're not going to be congruent. I'm going to write them as proportional.
Oh, okay.
First and second, first and second.
Yeah.
And it's going to relate. Remember, it's not a proportional unless we have an equal sign, right? We need two ratios being compared. And it relates to DE the same way BC does. And we also get AE and AC relate the same way. They all relate the same way.
Yeah.
Kind of like this, right? 3 relates to 6 the same way 4 relates to 8, the same way 5 relates to 10. They're similar, right?
Yeah.
Triangles are similar. Better?
Mm-hmm.
Okay.
Yeah, I see the connection now.
Right.
Because, like, when you, like, AD and, like, DE.
AD and AB go together, right?
Yeah.
Mm-hmm. Yep. So now we can say, look, I'm only interested in these letters, so I don't really care about that guy. Right, I got that for free. Here we are now, and I can rearrange it to get what I want. Does that make sense?
Yeah, yeah.
Hi, are you talking to me?
No, she's talking about the 0 days since you
okay.
thought about the duck thing.
Well, it is. Yeah, you've read that.
Yeah.
How do you feel about 3s?
Yeah.
Are you with me?
Yeah.
All
All right, I got another question about multiplication, so I need you guys to shut up so I can talk. All right, so we're good up to here?
Yeah.
Okay, I took that and wrote it down here. And then I did this idea. So x divided by 2 equals 5/9. To solve that, I want to get x on its own, right? So I times by 2, get rid of this. We good with this idea? Okay, great. It's the same concept, but over here. I want to get DE on its own. So I multiply by BC to both sides, and I get this. BC times AD divided by AB. And DC, or DE, comes on its own, okay? Are you with me there? Then I wanted to get BC and AD alone, because that's what I wanted up here, right? So I multiply by AB to both sides. And then I rearranged it, because BC times AD, same thing as AC, AD times BC. Are you better with that?
It's confusing.
So, let me make sure.
I just want to be able to apply.
So you understand what I'm saying, and you see the logic of it, but you don't know if you'd be able to do it on your own, because you just wouldn't know to do it. that's normal. This is the first time we've done something like this. We're gonna do more examples. And I think that, do you think that will help?
Most likely.
Okay, I think that would be the best way to go about it. If you're feeling about 30 to 35%, that's really good. Okay? I don't expect you to know all this right. That's why we're taking a week and a half. Okay? All right, you with me? Let's do number 6, and then we'll do number 5, and then we'll take a break. 6, here we go. That's the new thing I gave you, right? Page 5, number 6.
Oh.
All right, buckle up. It's going to get harder. You really need to understand the simple stuff before we get to number 4. 4 and probably 5 are going to kick your butt. They really will. But they won't if you really understand this stuff, okay? So you got to stay with me. Diana, I'm talking to you, especially since you're going on vacation, okay?
Oh, where are we going?
All right, AC and BC. Congruent. Alarm bells should be going off in your head right now. Katie, get with me.
I saw something.
AC and BC, congruent. Isosceles triangle theorem, we're going to end up using it, right? We also know ED is perpendicular to AC, so that means we get these two right angles, right? Same thing with EF and BC, they're perpendicular, so we get these two right angles. All right, what are we trying to prove? We're trying to prove that AD and BF relate the same way that AE and BE do. Words are hard, math is easy. Let me show you what I mean. AD is this segment right here, and BF is this segment right here. So we're going to show that they relate somehow, right? And they're going to relate the same way that AE, this bottom part, and BE, this bottom part, relate. Okay? So what we want to prove is these two triangles similar, right? If the triangles are similar, then their sides are proportional. You following me? Okay. So I need to get these two guys the same. Now remember, we have options. We can do A squiggle, we can do side, side, side squiggle, and we can do side, angle, side squiggle. Now, we know some stuff about sides, so sides are on the table here, right? But I think there's a really easy way to get this done, right? Macy's right. By isosceles triangle theorem, since this is an isosceles triangle, we know that the bottom angles are congruent, right? So, by isosceles triangle theorem, I can call that angle A because it's the only angle A. And I can call that angle B because that's the only angle B. Right? Yes?
Angle, squiggle.
That's right. So we're going to use AA squiggle, right? To prove that the two triangles are similar, right? By angle, squiggle. Triangle, I'll start with the left side triangle. That's ADE. Again, I try to do alphabetical order when I can. Squiggle, similar, right? Not congruent. Don't get in that habit of always writing congruent. ADE is similar to this triangle. Now let's match them up. A is going to go with what angle over here? B. D is going to go with what angle over here? F. And that means E must go with itself. So we could use CSP to prove that angle E here and here are the same. We could do that. But I don't care about that. I care about the sides. So now that these two are similar, I can use CSP to talk about their sides, right? By CSP, their sides will be proportional. So let's talk about their sides. I'm just going to write it all out. I might not need all of it, right? I only need 2. But I'm going to write it all out. So AD, what side is it going to relate to based on the letters? AD is going to relate to what?
BF.
BF, very good. Because they're first and second. And it's going to relate the same way. Remember, we need a proportion, right? We can't just write AD over BF. You're allowed to divide anything. That doesn't mean anything, right? But that they're equal says something. Next up is DE. What is DE going to relate to based on the letters? FE, very good.
Iron.
And then the last one, the one that I think a lot of people forget about, is first and third, right? So AE goes together. And that's going to go with what on the other triangle? BE, right? First and third over there.
The starting letters look like E.
So all of these are proportional. Now, do I know what proportion they are? Are they double? Are they triple? Are they half? Right? I don't know. Right? Maybe this is like 1.2 times the. I don't know. Right? We don't know, but we know they relate. Whatever it is, they relate. Okay? So everybody cool with that? Now, what am I interested in? AD and BF. That's this guy, and AE and BE. That's that guy. Well, if this equals that, and that equals this, by the transitive property, they equal each other, right? So I can just cut out the middleman and say AD over BF equals AE over BE swag. And I'm done. How do you like them apples? Yes.
Okay, so when do you use CSP?
You can only use CSP the same time that you can use CCP, right? CCP can only be used after you prove the triangle's congruent, right? CSP can only be used after you prove them similar. So CSP is going to help us talk about parts. So if they want us to prove something about parts of a triangle, we're going to end up using that. Okay? So just like when we did congruency, the goal, the general goal, right? There was no like, here, follow these 5 steps and you'll have a great proof. No, right? The idea was figure out what triangles you want to talk about, prove them congruent, and then talk about their parts using CCP, right? In here, it's figure out what triangles are relevant, prove them similar, use CSP to talk about their parts. Angles will be congruent, parts, or sides will be proportional. So you'll write that when you're talking about the sides, okay? All right, here we go, we're not done. 11. All right, we have plenty of time, guys. Here we go. 5, buckle up. We're taking a break after 5, okay? I'll probably let you go at that point. Here's my advice. Unless you're a genius, spoiler, not a single one of you is. You need to pay attention to this. You're not, okay?
Alrenton is quaking.
I don't care how smart you think you are. You kids like it for breakfast, okay? This is not the geometry every other kid in this country does. You guys are doing real geometry. Regular shapes class that other kids take is a joke. Because why even do the class? The question is, how many triangles are there? And you count them all up. Find the area. I'll give you the height. It's a waste of time. I don't want to do that. I don't want to do that. We're doing real geometry. And you guys come out of here as freaking geniuses. You guys, no pun intended, could run circles around other geometry classes. You really could. All right, so shut up and here we go. I need your attention. Mark, get with me. D is the midpoint of AC. I'm going quick, guys. Here we go. D is the midpoint of AC, so that means this. E is the midpoint of AB, so that means this. F is the midpoint of BC, so that means this.
I can't learn at this speed.
All right. I'm writing down what they gave us. D, midpoint, means it cuts that in half, right? That's what a midpoint means. E is the midpoint, so it cuts this in half. 2 equal pieces, yeah? F, midpoint, means these 2 pieces are the same. With me on that? Macy? Okay. Here's the deal. We need to prove that parts are proportional. And not just proportional, that we know that they relate in a ratio of 2 versus 1, right? 2 over 1 is 2, right?
Yes.
So what does that mean? Here's what it means. Look at AB and DF. AB is this. And we want to prove that it relates to DF, right? You see that? This side and that. And we want to prove that not only do they relate, but they relate in a ratio of 2 versus 1, meaning that this is double what this is. Okay? That's what we're going to prove, that this is double what that is. In other words, that this guy right here, just that, is congruent to this, right? If that's a single blue and that's a double blue, then this is twice as big as that, right? So that's what we want to prove. Additionally, we're going to prove that AB and DF also relate in another way, that they're parallel, that this is parallel to that. We're going to take one step at a time, okay? We're going to prove the first part first. The second part is not nearly as hard to prove as the back, okay? So here we go. First thing you should always look for is, do we have shared angles? Can we do something like that? So here's the thing. Notice the top triangle and the whole triangle share angle C. Does everybody see that? So by shared angle, this. Now, is there a lot of other information you can write down? Sure, but I want to be consistent here, okay? By angle, by shared side, right?
Yeah, at least
shared angle. God, second time I've done that here. My fault, not yours. I said God to me, not you. All right. Mr. Matt, get it together. Piece of garbage. All right. So this angle is shared for both. Are we cool with that? Top triangle and bottom triangle. This big triangle, I should say. All right. Are we cool with that? I'm going to prove that this triangle here is similar to this one here. Okay? Now, remember, the way we prove things similar is we have a couple options. We've got angle, angle, squiggle. We've got side, 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 squiggle. And we've got side, angle, side, squiggle. Okay? Now, remember, angles in similar triangles, congruent, right? Same angles, right? We've got some same angles. That's good. sides aren't going to be congruent, right? This side is not congruent to this, right? This is twice as big. They're not congruent, but they are proportional. Stay with me. This side is half of this, right? Isn't this side also half of that? Right? So this is proportional to that, the same way that this is proportional to that. So we have two sides that are proportional and an angle that's shared in between. I'm going to say it again. You guys are going to have to wait. It's okay. Keep your hands up.
No, it's not a question. Like, all right, you can explain.
This side is half of this side. Do you see that? And this side is half of that side. Are these sides equal? No, we don't know that, right? But we know that that's half of this and that's half of that. So they are proportional, right? If that was 3, that'd be 6. If that was 4, that'd be 8, right? They relate the same way, half. So I'm going to write that. I'm going to say that CD relates to the whole thing, AC, the whole thing, right? These guys are equal. These guys relate. You smell them stepping in? This piece relates to the whole thing. The same way, equal sign, that CF relates to BC, the whole thing on the other side. So again, this relates to this the same way this guy relates to that. They're both half of the bigger thing, right? So I'm going to write that. They relate by half. The idea is saying if CD were 1, what would AC be? 2. Now, hold on. How do we know it's 1 and 2? How do we know that? Couldn't it be like 3 and 6, or 4 and 8, or 5 and 10, or pi and double pi? It could. But what do 3 and 6, 4 and 8, 5 and 10, pi and double pi all reduce to? Half. So whatever they are, whatever the numbers are, they're going to reduce to this, right? So they relate by half. Are you smelling what I'm stepping in here? Again, I started with small piece going to big piece, so I got a half. If I did big piece going to small piece, it would have been double, right? CD is 1, that means AC would be 2. We cool with that? Same thing here. If this was 1, that'd be 2. Yes?
So in the beginning when you made like the squiggle thing, how did you know like which ones that you could use?
We learned that the other day when you were gone.
Okay.
These ones, those ones that work okay. Yes?
So like, I was thinking like instead of doing that, is there a way we could do like SAP, and then we could just do like the isosceles triangle theorem?
No, we don't have any isosceles triangles here. This is not equal to that.
Oh.
Yep. Okay, cool. All right, thanks for waiting, Mark. All right, so now what does this mean? We've showed we have congruent angle. Stay with me. We have congruent angles, right? And we have proportional sides. So I can use side angle side similarity. So I'm going to do that. By side angle side similarity, I know that the top triangle, triangle ADF, is similar to the big triangle. Let's match them up. Oh, not ADF, sorry, CDF, my bad. CDF is the top triangle. C goes with C, right? Angle D is this angle. Notice angle D is made up of the red side and the unknown side. So red proportional side and unknown side, I don't have any blue here, right? It's going to be A. D goes with A. Does everybody see that? Red and unknown goes with red and, well, the thing we don't know about yet. Everybody cool with that? F, this angle is made up of the green side and the unknown, so green proportional and unknown would be B. Okay? Are you with me on that? Now I got those letters. Rad. All right, so now I know top triangle and bottom, or the big triangle, are similar, so I can say by CSP a lot of things. I want to prove that their parts are proportional. Namely, that DF is proportional to this. So the bottom of the top triangle, proportional to the bottom of the big triangle, okay? So I'm going to say by CSP, DF is proportional to AB. Right? How do I know DF and AB go together? Check it out. DF is second and third. AB is second and third. And it'll be proportional in the same way as the other sides were, right? CD and CA and CF and BC from earlier, right? If this side's proportional to this, and the green side's proportional to the big green, then this must be a blue side that's proportional to the big blue. And they all are proportional in what way? What do they all relate to? The relationship is what? 1/2. Now notice what they wanted is for all those to be related to equal 2. But check it out. I have DF over AB, and that gets me a half, right? They have AB over DF, that gets us 2, right? Well, that's because they flipped everything. So I'm going to rewrite that. Therefore, AB over DF and CA over CD and BC over CF are all going to equal 2 over 1, which we can reduce to what? What's 2 over 1? 2. First part of the proof done. Not only do I know they relate, right? We can prove that for lots of triangles, right? But that they actually, this is going to be half of this. So what does this mean? Check it out. These segments are just connecting the midpoints of our triangles, right? So for any triangle, if I connect the midpoints, right? This will be double whatever that is. And this will be double whatever that is. And this will be double whatever this is. Are you smelling what I'm stepping in here? I got you at about 50. No. No? Do I have you up to here?
Yeah.
Then by SAS squiggle, because I've proven that sides are proportional, and I've proven that we have an angle, right? I can say the triangles are similar. Then by CSP, CD goes with CA, like we said before, right? And DF goes with AB, right? And CF and CD go together. And how do they all relate? See how these were already a half, so if I tack that on, it's also a half. I can flip all these, and now I've got AB on top, CA on top, and BC on top. That flips this. Better? Okay. So I've done that, yes.
So basically, like the bottom part, it just means you're doing like the reciprocal thing.
Yep. Mm-hmm.
Okay.
It's true both ways, right? The idea is that this is half of that, right? But I could also say this is double that, right? Depends on which way they look at it, right? That's why they're related. Okay? The relationship's the same, it's just a different way of looking at it. Dollerschlager and Barehand switch spots. I think it'll work out better for everybody involved. Bless you.
Thank you.
Sorry, Barehands.
That hurt.
All right.
Ow.
We're not done. We also want to prove that these things are parallel, right? So again, don't be overwhelmed by all the letters. Words are hard, math is easy, right? AB is this down here, and DF is this up here. We want to prove them parallel. Remember CAP, corresponding angles postulate. It says that if the lines are parallel, then the corresponding angles be congruent, right? You smell what's happening? The converse of that is if the angles are congruent, then the lines are parallel. You dig? So what we're going to do to prove this parallel to that is prove that this angle here is the same as that angle there. That makes sense? Corresponding angles, top right corner of the intersection. So here's what I'm going to do. Because the triangles are similar, right? Didn't I prove this triangle similar to that triangle already? Similar triangles have congruent angles, right? So I'm going to say by CSP as well, right? Can you see them right? No, not really, but now you can. By CSP again, this angle here, let's use, come on. Let's use like oh, here. This angle here is congruent to that angle there. How do I know that? Well, look, this angle is CDF. Look back up here. CDF. CDF, right, should be congruent to angle CAB. CDF, CAB. You did? So it's by CSP, I know angle CDF is congruent to CAB. Can I do that for the other side and get this angle and that angle the same? Yes. But how many angles do I need to prove congruent to prove they're parallel? Just one set, right? So now I'm going to say by cap, yes, by cap converse. Remember, cap normally is parallel lines, means those angles are the same, right? I'm saying those angles are the same, so these are parallel lines. So I'm doing the reverse, the converse. I know that AB is parallel to DF. So I can add a little parallel sign here. How do you feel about that? I was able to prove these two angles the same by using CSP. See how the triangles are similar? So then I can say CDF, that angle will be the same as CAB because they're first, second, third, right? I could also prove that angle DFC is the same as angle ABC, right? But those aren't the ones I was interested in. And if those angles are the same by cap converse, these are parallel. Do you see it better now? Means that these two must be parallel, right? Follow one second. Now here's what I'm gonna do. I could do that again for this side and then prove, right? All that stuff. I'm gonna say by same dumb logic, it'll work for everything else too. It'll be the same thing I just wrote here, but I'll use different angles. I'll use these angles, right? And that'll prove that this is parallel to that, okay? And then I'll use I did, oh my god, this one and this one. I did this one and this one. I need to do this one and that one. So I would say by these angles being the same, let me get another color, orange. Right, this angle here, actually let me purple. By these two angles being the same, I can prove that these are parallel, right? So I'm just going to say by the same dumb logic, I get all the rest. So I'm going to say by similar, haha, logic, get it, similar. AB parallel to DF, comma, BC will be parallel to DE, comma, AC will be parallel to EF. And now I'm done. All right. So what have we proven? For any triangle that I draw, no matter how weird it is, if I find its midpoints for each side, right? If those are midpoints and I connect them, this side will be twice as big as that. And this side will be twice as big as this. And this will be twice as big as that. Not only that, but this side will be parallel to this side. And vice versa. This is true for any triangle. We call this the midpoint, mid-segment theorem. These are mid-segments because they connect midpoints. The mid-segments of the triangle will always be parallel to the opposite side. And they'll always be half. So now that we have that theorem, we never have to write this again. We can just use that whenever we see something like this. It's super useful. So if I told you that that's 6, are those midpoints? Yes, so we have a mid-segment, right? Halfway, halfway. If that's 6, how long would that be? 3. And we say by mid-segment theorem, which we just proved. Not only that, but that's parallel to that, which means these angles are the same. You get a lot of stuff out of that. The beauty of theorems is it says once you've proven it, you can use that theorem and say, look, all of that I get for free. By mid-segment theorem, boom. That's 3 and those are parallel. Alright? We're not going to use mid-segment theorem yet. It's going to be a while, right? We're still going to have to prove this on quizzes and stuff, okay? But eventually we'll have that shortcut. Kind of like how we used to have to prove linear pair theorem and all those ones we just take for granted now, segment addition postulate, right? Cool.
Mr. Mack.
See you tomorrow.
Can I
Be
switch
ready
this?
for tomorrow.
Can we do
Kobe! Yeah.
Kobe.
Rosa buckets! But also goodbye world. Recycle. Bye, see you tomorrow. Be safe, get healthy. Don't come to school if you're sick. Do not be leave, we cancel. See you in homeroom if you need help.
I am already sick. I can feel it. Also, Mac,
Yes.
I need you to else sign or something.